Hi, and this is an extension to section 3.6. I'm just going to call this lesson 3.6b. And right now we're on page 174, and this section is called Applying Proportions to Similar Triangles. Now, you know in the last two sections we have been working on setting up and solving proportions. And in this section we're going to use that to solve proportions in similar triangles, and I guess I could have put figures here because we will do more than just triangles. We'll also solve similar figures too, but we'll concentrate mainly on triangles. And before, as I do with all my videos, before we get into actually how we can use proportions to solve similar figures or triangles, there's some vocabulary we have to know and some things we have to know first off, okay? And the first of those things would be, what is congruent figures? When you hear congruent, congruent means you have figures that are the same size and they're the same shape. So I hope I drew a good picture here. I wanted to give you an example of that. And by the way, before I show you my picture, congruent has a special symbol, and it's this one right here. It's an equal sign with a little wave over it. This is the symbol for congruent. Okay, a little equal sign with a little wave over it, that stands for congruent. So when you see that, that is saying that two figures are congruent. That means they're the same size, same shape. I tried to draw a picture, I hope I did a good job, of two triangles that are the same size, same shape. Now it's important when you name these triangles and you say they're congruent that you have their corresponding parts matching up or aligning. Like if you look at my picture, can you see that in my picture, angle A kind of is matched up with D. These are the same angle on each triangle. And angle B and angle E are the same part on each triangle. That's what the word corresponding refers to. Okay, they're in the same position, same relative part on each triangle in this case. C and F are corresponding. C and F correspond. So do you notice when I named my first triangle, let me erase those out. When I named my first triangle, will it let me? It's not letting me erase it out. Okay, so when I named my first triangle, I guess it just did, ABC, then when it's congruent, I have to name my second triangle DEF because A matches D, B matches E, C matches F. It would be wrong, it would be incorrect, let me write this in red, it would be incorrect for me to write triangle ABC is congruent to triangle EDF, because if I do that, I am saying that angle A is corresponding with angle E, and obviously A and E are not in the same relative position on each triangle. There's one other vocabulary word we got to quickly discuss, and that's the term similar. When you have similar figures, that means we have two figures with the same shape, but not necessarily the same size. The symbol for similar is just this. You can see it's that same symbol for congruent, but there's no equal with it. So this is my symbol for similar. All right, an example of similar triangles. Let me see if I can actually draw this up. I don't know that I can, but I'm going to try. Let me try drawing similar triangles. Okay, we'll try that. It looks to me like if I name this triangle I just drew, it looks to me like triangle, I'll call this triangle XYZ. It looks like XYZ and ABC are the same shape, but they're obviously not the same size. And it looks like angle X corresponds to A, Y to B, and Z to C. Well, I could say that triangle XYZ is similar to triangle ABC. Similar means same shape, not the same size. Okay? Now, with that, something else important we need to talk about. Go to the middle of page 174. When you have similar figures, there are special properties that are true in similar figures. So maybe I'm just going to write similar figure properties. And these properties are very important to understand. So let me draw, again, let me just go ahead and draw two triangles like they do in the book. And here's one triangle, and here's another. And we're going to set these are similar. So let me see if I can draw them that they look the same, but they're not the same size. And I think that's probably, well, I'm trying as best I can. I hope I can. I think that's pretty good, okay? So I'll call this triangle ABC, and I'll call this triangle XYZ. And let's say that I drew this picture well. I'm hoping I drew it well. And let's say that these two triangles are indeed similar. Now, when they're similar, that means there's some very special characteristics that we have to be aware of. Okay? Whenever you hear that word similar, here's the first characteristic. Okay? Corresponding angles are equal, or I should say congruent. Corresponding angles are congruent. Okay, here's what that means. That means if angle A is 90 degrees, since these two triangles are similar, then that means angle X would have to be the same thing. If angle C is, we'll say that angle, I don't know what it is, but let's say angle C, I'll just pretend, let's pretend it's 30 degrees. That would mean angle Z would also have to be 30 degrees because these are similar triangles. If angle B was 60 degrees, that means angle Y would have to be 60 degrees because the angles must be, corresponding angles must be congruent, which means equal measure, when you have similar triangles. That is always true when you have similar triangles. Now, I don't know if this is 30, and I don't know if this is 60. So I'm just going to use symbols. When you see a single arc, that means that this measure and this measure are the same. They both have a single arc. Or here I have a double arc. A double arc means that, okay, whatever angle measure Y is, B would be the same. So again, similar figures have corresponding angles. Here's another important property of similar figures, a second. If you take the ratio of the sides of each similar triangle, these ratios should be equal. Now you might be like, what the heck did you just say? Here's what I'm trying to say. If I take side AB and compare it to side XY, that ratio should be the exact same amount as BC compared to YZ, and that ratio should be the same as AC compared to XZ. Now, I talked about that a little bit abstract. These ratios have to be the same. The side length of this small triangle, since they're similar, compared to the big side, or I misspoke. The side length of AB on the small triangle compared to the side length of XY on the larger should give me the exact same ratio as the side length of BC on the small triangle compared to YZ on the big triangle, and so on. Okay, so let me just, and I'm just going to follow what's in the book right now. They gave you two triangles, and I'll do the same thing. Let's pretend that this triangle had measures of 3, 4, and 5, and that this side here was 6. And I want to find these missing sides. I can find that using the ratio of AB compared to XY. So let me just write this in. AB is 3 and XY is 6. Do you see how that gives me a ratio of a half? 3, 6 is a half. Well, since the ratio comparing this side to this side is a half, the ratio comparing any of these sides should give me half. So in other words, if BC is 5, then I know YZ has to be a 10 because it's got to give me ratio half. And I know that if AC is 4, then XY would have to be, or I'm sorry, XZ I meant to say, XZ would have to be an 8 because 4/8 is a half. Now let's pretend that I didn't know that. Pretend I couldn't figure out in my head what does this need to be to make half. Well, what I could do is use a variable, and do you see a little proportion here? I could do 5 times x equals 10 times 4, which is 40, and then divide each side by 5. And when I do that, x equals 8. Okay, if I didn't know that this was 8, I could have just figured it out now using a proportion, which gets me back to what this whole lesson's about. It's about you using a proportion to solve similar figures. So that's going to get us to a worksheet and the bookwork. In this worksheet, they're going to ask us questions. Down here, we'll do one of them together to get you going on it, and I'll give you the worksheet tomorrow. It says they want me to find the measures of the missing sides of these triangles. So for each set of measures given for triangles ABC and DEF, and by the way, these triangles are similar, they told us that in the directions, we want to find all the missing measures. Okay, so they told me on this triangle, A is 10, I'm just going to write it in, A is a 10, B is a 12, C is a 6. And on this triangle, D is a 6. And they told me right here that A, B, C, and D, E, F are similar. Okay, now that's what this is what that means. That means that side AB matches DE. So AB compared to DE has to be equal to, okay, now let me take a different color, has to be equal to, can you see BC? BC and DF, or I'm sorry, BC and I misspoke, EF I meant to say. So BC is compared to EF. And then let me erase this, and I'll use black for my last comparison. And then that has to equal AC compared to DF. I can just see that right in how they wrote those in that similar statement. These two triangles are similar. Well, this is going to be easy now, okay? Let me use black. Ready? It said AB. Well, AB is 6. I know AB is a 6. BC is a 10. And AC is a 12. And then over here, EF is a 6. I want to find DE, I'll call that X, and I want to find DF, I'll call that Y. Well, this is easy. I can definitely figure this out. First of all, start with this proportion. 10 times X has to equal 6 times 6. Divide each side by 10. Well, X had to equal 3.6. So I just figured out that DE, right here, this has to be a 3.6. Now, let me use a different color. Let's go over here. I want to find Y. Well, that's easy. I'm going to circle this proportion. 10 over 6 has to equal 12 over Y. All I need to do is cross multiply. 10Y has to equal 6 times 12, 72. Divide each side by 10, and I'm getting 7.2. I just found out that DF is a 7.2. And I just found all the missing sides of the triangles. Okay? And that's how you do the rest of the sheet. For number 4, let me just erase this. For question number 4, all you do is, I'm just going to erase this, and I'm going to use the same picture again. I'm going to say A is 16, B is 22, C is 12, and F this time is 8. I'm going to use the same 3 ratios. I could write them all out and fill these numbers in, and I have 2 proportions that I can solve. Okay? I'm going to stop this video here. The book works, same material. I am just trying to solve for these ratios that I set up within my proportion. If you have more questions, we can talk about this obviously more tomorrow.